Hello, everyone. Thanks for joining us for this on-demand webinar. Our topic today is using a semantic and graph-based data catalog in a modern data fabric. My name's Barbara Petroselli. I'm part of the team here at Cambridge Semantics, and my focus is really on our pre-sales organization and strategy. And I'm joined by my colleague, Greg West, who's also part of our pre-sales team. I'm going to start our conversation today talking a little bit about this idea of using a data catalog based on semantic and graph technology as part of a modern IT or data management stack, what we call a data fabric. I'll be pretty quick, and then Greg is going to follow up by showing us that in action with a little bit of a demonstration using our solution, Anzo. So as we get started here, let's just think about this particular challenge. This is really ubiquitous today across organizations, and it really is the center of what we're thinking about here at Cambridge Semantics with our platform. The real issue a lot of companies are facing is that they really need to find new ways that allow them to bring much more of their enterprise data forward towards the data consumers in the business. And to do that in a way that makes the data accurate, understandable, accessible, usable on a pretty self-service basis. This is all driven, of course, by digital transformation and the analytics revolution. And the problem is that the existing technologies most companies have used heretofore to achieve this goal really can't meet the demand. They're not fast enough, they're not flexible enough, they don't allow enough people in the business to participate in the process. And the outcome of that is that a lot of organizations are really trying to think about how to stand up a new modern stack of technology to enable their analytic imperatives. At Cambridge Semantics, we think about this in terms of the concept of a data fabric. And we didn't come up with the term. Forrester did a couple of years ago, Forrester Research. And the idea of a data fabric is that you maybe look at a new set of technologies that allow you to bring more data forward towards that business, again, in a governed, controlled way, but where the data is much more self-describing, business-oriented, so that more people can leverage it. And in that stack, we really think that this idea of a data catalog exists kind of in this middle layer that I'm highlighting here. So you think about it starting at the bottom, you have a set of source systems that might be on-prem or in the cloud, and you're ingesting data from those into some persistent data layer, right, where it's being staged for further preparation, integration, blending. And then above that, you have some layers that provide data orchestration that help to bring data together, to clean it, to harmonize it, to integrate it, to standardize it, to bring it more towards some business model. And so on top of that, there's a layer of business concepts, designs, modeling that allows at the very top layer, that being access to the data by data consumers, to be pretty self-sufficient and broad across the organization. And we think catalogs live really in this middle place, sort of in that data orchestration, data discovery component. So as we move forward in this, here's one way to think about data catalogs. When you look at the data catalog solutions that are in the market today, there's a whole group that really originated out of the data warehousing revolution in the 90s. And that's when we began replicating and ETLing a whole lot of data out of source systems into analytic platforms, warehouses, and data marts. And the purpose of these catalogs was really around control, quality, and governance. Originally, most of these platforms were thought of as metadata management platforms, and their objective was to document what data exists in the organization and then add a layer of context with things like business definitions and glossaries to describe that data. Fast forward to 2010, and really a new generation of catalogs emerged, and their origin story was out of the data lake. So this was where everybody was moving data, again, out of operational systems, generally into Hadoop environments, and then discovering that Hadoop alone really didn't offer the sort of controls around governance, search, quality controls, access controls, or cataloging. And so products like Zaloni or Podium or Elation were created really to try and lay over the lake, add that context in a catalog, and make the data accessible. Our approach to cataloging is distinctly different from both of these groups. Really what we're focused on is three key things: making complicated enterprise data simple, bridging the gaps between operational systems or sources, siloed data sources, blending data together, adding into that business context and meaning, and then making that available to the business. So simplifying data, blending data, and making it more accessible and usable by adding business context. That's our unique point of view and approach to cataloging, and I think you'll see that as we move forward in our conversation. So our product, which Greg is going to give you a little tour of in a moment or two, is called Anzo. And Anzo is a data discovery and integration platform that's part of that data fabric. And it really provides a modern approach to data cataloging built on semantic and graph technology. So we really have three core capabilities. The first thing Anzo does, it lets you build a visual map of all your enterprise data. It lets you onboard and integrate metadata and data from various siloed source systems to harmonize that and align that and integrate that using graph data models, and then bring more business context and meaning using semantics. So it creates this fantastic, very supple, explorable, comprehensive catalog of enterprise information. The second thing it does is let users then go to that catalog and search through it to find the data they might need for an analytic project, to find, explore, select, filter, optimize the data set they're interested in, and then publish that out for consumption in whatever tool they're using. And the third thing it does is provide all of those services in a framework of enterprise scale data management capabilities. So everything you would expect from a large application around governance, security, quality, et cetera, is part of the Anzo platform. So bottom line, there are three key ways that Anzo as a data cataloging solution is distinctly different, and we would argue better than traditional cataloging approaches. I'm going to talk about these in detail in a moment using a couple of illustrations, but in a nutshell, Anzo maps the physical or logical layer of data into a business layer using semantics, so it makes the data more understandable. Secondly, it goes beyond just cataloging, documenting what data exists in the environment. It inherently also takes step towards doing some data cleansing and integration as part of that process. And finally, it not only collects information about the data that exists within an organization, it also connects back to that data. So the moment you find the data that you want, you can go and get that data and bring it back for use in your particular analytic ready data set. So let's take a look at those three ideas in a little more depth. So the first thing I mentioned was that Anzo bridges the gap between the physical metadata describing data sources and the business meaning. So we do that by inserting a layer of semantic context into the data collection. So working left to right, think about the data supply chain. The first thing you do might be to ingest data from source systems into some platform. And as we do that, we automatically map metadata from those sources, the schema, the tables, et cetera, whatever's there, into semantic models or concepts. And the benefit of that is it makes the data much easier to view and understand, not in terms of table definitions or data types, but business concepts. At that point, you're building a collection of raw data. And your subject matter experts or your data ops people or data engineers are going to want to look through that data and understand what's really there. And again, viewing that data through semantics as opposed to technical metadata from the source system makes it much easier to understand, allows you to see connections between siloed data sources or where data is related. The semantics are also part of how we conform data. So when we ingest data from various siloed systems, which has each source having its own schema and format, we use semantics to begin harmonize, align, and integrate that data around a common model. And then to begin enhancing that collection, building bespoke data sets that might be purpose-built for a particular analytic project or need, and then exposing them. So again, at the far end of this process where end users come to the catalog to search for data that they need, rather than looking through technical metadata or superimposed business definitions, they're looking at the data in terms of data concepts. For example, all of the data that relates to an auto insurance policy or a healthcare claim or a retail transaction. And that data might originate lots and lots of different systems, but for the user, all they know is they're looking at that business concept, a claim, a policy, a purchase. The second thing I mentioned is that in our approach to cataloging, we not only catalog data, But inherent in the process, we do some cleansing and integration of the data, and you'll see that in the demo Greg's going to give you. This is important because this is a recognized trend in the industry. So these siloed point solutions, quality, governance, integration, modeling, which in the past were really separate applications where data was sort of passed daisy chain from one solution to another, those barriers are being broken down as part of the effort to accelerate data delivery. And our product, the way it works and the way it addresses cataloging, is absolutely aligned with that trend. And the third thing I mentioned was that we not only collect, but also connect to data as part of our cataloging process. So let me quickly walk you through what that looks like, and then we'll get to the demo. Here's an example with a very simplified example using healthcare data. So imagine you had some relational data source in your environment that tracked claims data, and each row of data was a separate claim. When we onboard that data, we automatically convert it from its existing format, rows and tables and columns, into a graph data model. So we might, for example, looking on the left in orange, create a new concept called a subscriber, and that subscriber is related to a claim. And a subscriber has some properties like a subscriber ID, and the claim has some properties like a claim ID and a processing date. So we do that first with our claims database, and then we do it again with our data source containing electronic health records. And once again, we convert rows and columns of data into concepts. But we see something new, that the object patient record from our electronic health records data source is actually the same as our subscriber in our claims database. So we're going to recognize that those are both people with unique identifiers by connecting them together. And then we keep going, and we can do this with unstructured sources as well. For example, a doctor's note, where we use NLP and annotators to read through the text, extract out key relevant facts. For example, this is a note about a particular person who had a headache and nausea. The note had a particular date, and connect that back to a patient record. So the first step for us is to onboard data and convert it into graph data models. The next thing we do is bring semantics in. So the dark blue on the left and the orange and the purpley gray on the right are actual real data sources that we onboarded. But then we can create a virtual layer, essentially a canonical model that and map the data from those three separate sources into the model. And this allows us then to connect data. This is where we're breaking down the silos across sources by defining relationships. For example, the idea of a patient. Patient exists in the electronic medical records. Patients' costs are related to both claims and electronic medical records, et cetera. And as we're doing this, we're tracking the entire process through metadata. So this model tells you that as you onboard data and you change the format of it and you map it into a canonical model and you begin building it into data sets, which we call graph data sets, blending it and then publishing out for access, all of that is documented through metadata. So when all that work is done, this is the user's experience. They come to this collection of data, this catalog that we built, and they search around, step one, to discover and explore what's in there and what they might want. And when they find the data they want, they go to step two. They push a button, which automatically subsets out from the overall collection the particular data that they want. Now you're at step three. Now they have that subset, and they've said, okay, I think this is what I need for my project, and they have an option. They can either visually explore that inside of our platform Anzo, or they can publish it out for consumption with things like Microsoft Power BI, Click, whatever it is that they want to use. And the real magic of this is once you've built this catalog, once you've onboarded data and you've blended it and brought in semantics and built this model, you can come to the same source over and over and over again to build separate, distinct, bespoke data sets for different projects. So you just keep spawning new sets off of this overall collection to address needs over and over and over again. And it really accelerates data delivery, enables reuse, creates a much more self-service, democratized data access model inside the organization. So with that, I want to switch over to Greg and take a look at what this really looks like inside the Anzo platform.
So let's talk about a typical enterprise data cataloging problem. You have data architect and their team of data engineers, and they have really data all over the enterprise, in the enterprise data lake. We're talking about, a variety of different relational databases, unstructured files coming in from customers or being passed between different users within the enterprise. You have structured files such as JSON and XML, and then you may even have CSV and Excel files that different data scientists want to bring in and do analysis with. So there's really two main questions, the data architect is going to have, right? What data has my enterprise collected, throughout the enterprise data lake? And then as a second question, how do I connect these different data sources to begin to answer questions? So the first step is to create a searchable catalog of data. And with Anzo, we do this, through our onboarding process, where we bring in different data sets from different sources, and we can attribute metadata to those different sources and allow you to search them based on the metadata. And you're seeing a visual of that over on the right. And once that is complete, there's really a second step. And that's to connect some of those selected data sets to begin to answer specific questions. And you're seeing this view of this model over here on the right, and that's being created from the different data sets that have been assembled and created as a data product. So we kind of assemble here, and what we do is we end up stitching them together with a series of data layers and queries where we can combine these different data sets in memory. And again, we will see this during the demo. So let's move over and look at the Anzo platform. So just a very quick overview of what we're going to see during this demo. This is an insurance example using some automotive data that is public from the state of New York. So we're going to walk you through the process of bringing on some of the different data sources, and we're going to start with briefly covering onboarding and modeling, and then we will talk much more extensively about the data set catalog and how we can really do some analysis on the underlying data sets. So if we start with onboarding here, we have ways of onboarding lots of different types of structured sources. They can be a relational database, they can be CSV, JSON, XML, even SAS files. We also have ways of bringing on unstructured data where we connect to a document repository and we search for a list of known entities. If we want to go into that in more detail, maybe you should follow up with us. But if we talk about connecting to a structured data source, I'm just going to choose one as an example here. What we do as we import these different structured data sources, that we're able to extract metadata from the source. That metadata are the different columns and the column types, even some sample data from that source, as well as the foreign key relationships that connect those different sources. And what we're able to, those different tables. And what we're able to do from the metadata that we are able to extract is we're able to build a graphical model of that data source when we ingest it. So let's take a look at what that model looks like, just this specific source. So as you can see here, we've taken these two different tables that exist in our New York municipality database, and we've created a graphical expression of the schema and underlying metadata. So the big point here is what we've done is we've mapped the physical layer, what's actually in the rows and columns in a database, to a business layer that your business users may begin to understand. The other thing that gets created as we ingest the different structured and unstructured sources is really this quite large data set catalog of different ingested sources. So in this particular example, I think there are roughly a couple hundred different sources that have been onboarded, and you can search this this catalog, right, by any of the classes of interest. So if I'm interested in data set that has information with car makes in it, you can search for that particular class. You can also search by any of the custom metadata tags that have been generated for these different sources. So if I search for this New York Auto tag, we can find the different data sets that have information about New York Auto relevance. and I can click into any one of these data sets to drive into different data set details and metrics. So if I click on this particular data set again, now after it's been onboarded, we can actually see some metrics about this data set, so we can begin to do some profiling and analysis just at the metadata level. Now, as a data engineer, as a data architect, what am I really looking to do once I've sort of cataloged this whole set of data sets? So I've done step one. I now have collected all my different enterprise data sources, or maybe not all of them, but I've a fair amount of them, and I'm continuing to onboard more. But my business users are clamoring for data products, and they want them much more quickly than I'm currently able to get them out. So what I want to do, right, is build what we call a graph mart. A graph mart is a collection of data sets. You can see we can just create it with this little shopping cart experience. In this case, we've already created one. And a graph mart is really just a data product that consists of one or more data sets. Each one of these data sets is loaded into memory as an in-memory data layer. Now, it's possible to validate and transform these data layers in memory, and I can show you what that looks like down here, where we have this step called blend data sources. And what this blend step is doing is actually creating some custom connections between the different data sets above via Sparkle queries. And it can also do transformation and validation on the data. So if you have bad data that you want to transform or do some validation on, you can do it in these queries, because they're ELT transformations that are transforming the data in memory. So you're very quickly able to iterate on the data products that you can provide out. So we can look at this particular query. This is linking a crash with a given location based off of a matching municipality location. And once we've loaded this into memory, we can begin to analyze it either using there's actually no data and a JDBC endpoint that you can activate for a graph mart, but there's also a tool that we call Anzo HighRes, which is Anzo's built-in visualization tool that's just aimed much more at those business users that can explore the data that we prepared for them. So let's take a look at that. So we have a couple of different dashboards where we can actually do exploration on the data here. The first one, we're actually just going to explore some of that metadata. And when we can explore by the metadata, right, we can explore, based off of the column type or the column name. So if I'm interested in finding data sources that have phone numbers in them, I can search for the different data sources that have phones. So it looks like, different files, shippers, suppliers, customers all have a phone number. You can, get a breakdown of the most common field names and the most common types over here on the right. So there's a lot of different ways that we can break down the metadata. But because we've now connected the data with the underlying metadata, we can also begin to explore the different data sets that we've brought up into our graph mart. And let's take a look at this use case. So this is a sample dashboard that we built that actually looks at some of those automobile crashes in the state of New York, and we're bringing in data from, I think, about a half a dozen different data sets here. It's different county information, crash information, some information from the National Weather Service about the weather on particular days that we've correlated with these different accidents. And we can have different visualizations we can filter on. So we can filter on where the crash occurred. We can even have some charts on, what was the crash versus the temperature. So you can see the most common temperature. Actually, the warmer it gets, it seems like the more crashes we have, maybe because more people are out driving. We even have, visualization about when crashes occur. So again, sort of that 5 o'clock rush is when more accidents are happening. So there's, we're allowing our business users to explore the data that has been prepared for them very quickly. And that's because Anzo hasn't just, collected the underlying metadata, but we've also connected the data back to that.
Okay, Greg, thank you very much for that. We hope that what you've heard today is interesting to you and that it's given you some things to think about in terms of the potential role of our solution Anzo as a data catalog in your environment. We would love to continue the conversation. Please feel free to reach out to myself or Greg via email, or take a moment and visit our website, where you will find a wealth of information about our platform, about customers, about not only our technology, but how people are using it in enterprise scale production deployments today. And with that, let's end today's webinar. Thanks.